A particle crosses an empty room, and before anyone looks, it behaves as if it has taken more than one path. A sound troubles a small desert town, but the machines brought in to capture it hear almost nothing. Lights hover above a Norwegian valley for decades, bright enough to be photographed, elusive enough to remain unnamed. Is reality a fixed state, or a program with bugs? That question sounds like it belongs to science fiction, and for good reason. The internet is crowded with stories of glitches, vanishing objects, impossible memories, and moments that feel designed more for fear than understanding. But today, we are not looking at creepypastas. We are looking at cases connected to sensor data, photographic evidence, laboratory observations, historical artifacts, and serious investigations. Some are well-established science. Some are disputed. Some sit in a fragile space between evidence and interpretation. Together, they do not give us a final answer. They give us something more unsettling, and perhaps more honest. A reason to wonder whether the world around us is less solid, less complete, and less fully understood than it appears. By the end, reality may not seem broken. It may simply seem unfinished. The first anomaly begins not in a haunted house, but in a laboratory, under controlled light, with equipment built to remove mystery rather than create it. The double-slit experiment is one of the most famous demonstrations in physics because it forces a question that still feels almost impossible to absorb. When particles such as electrons are sent toward two narrow openings, they can form an interference pattern, the kind of pattern we expect from waves. It is as though each particle spreads out, passes through both slits, and meets itself on the other side. Then comes the strange part. When researchers try to determine which slit the particle actually passes through, the wave-like pattern fades. The particle begins to behave more like a localized object. Measurement changes what can be observed. In 1998, researchers at the Weizmann Institute explored this problem with delicate detection methods, showing that the stronger the act of observing, the more the interference weakened. The result did not prove consciousness shapes matter. It did not mean the universe waits for human eyes. But it did show something deeply uncomfortable. Observation is not passive. To anyone raised on the idea of a solid, independent world, this feels like a crack in the floor. Matter seems to have options until an interaction demands an answer. And that answer leads to a modern metaphor that is difficult to ignore. In a video game, the world beyond the player's view is often simplified. Mountains, streets, rooms, and objects may not be fully rendered until they are needed. Developers call this kind of optimization by different names, but the principle is simple. Why spend resources drawing what no one can see? Some people have compared the quantum measurement problem to this idea, especially the way particles seem to hold multiple possible states until a measurement narrows the outcome. The comparison is not proof that reality is simulated. It is a metaphor, and a risky one. But it survives because it captures the emotional strangeness of the science. The universe appears to conserve something. Not energy in the ordinary sense, but definite information. At small scales, nature does not always seem to carry a single finished answer waiting to be revealed. Sometimes the answer appears only when the question is asked in a physical way. This is where wonder should be careful. The double-slit experiment is not a magic trick, and it is not a permission slip for fantasy. It is a precise scientific puzzle, repeated in many forms, interpreted through mathematics that works with astonishing accuracy. Still, the human mind hears the result and feels an ancient unease. If matter does not always behave like matter until it interacts, then the visible world may be more like a surface than a foundation. And far from the laboratory, in a cold Norwegian valley, another surface begins to glow. The Hessdalen Valley in Norway does not look like a place where physics should lose its footing. It is quiet, rural, and severe, shaped by mountains, snow, and long northern darkness. Yet for decades, witnesses have reported strange lights moving across the sky and the landscape there, sometimes hovering, sometimes racing, sometimes splitting into separate points and merging again. During the early 1980s, the reports became frequent enough that scientists organized monitoring efforts. Cameras, radar, magnetometers, and other instruments were brought into the valley. The goal was not to confirm a legend. It was to measure whatever people were seeing. Some of the Hessdalen Lights were likely ordinary phenomena: aircraft, planets, atmospheric effects, or misidentified objects. But not all reports dissolved that easily. Automated cameras captured luminous forms. Instruments recorded unusual readings. The lights sometimes appeared as bright orbs, with behavior that seemed difficult to explain through a single simple mechanism. Various hypotheses have been offered: plasma effects, combustion processes, ionized dust, geological stresses, atmospheric electricity. None has completely closed the case. The phenomenon remains not proof of another world, but a reminder that our own world contains processes we have not fully mapped. What makes Hessdalen powerful is not that it confirms one extraordinary explanation. It is that it has endured measurement. A mystery is different after it has passed through an instrument. It becomes harder to dismiss, but not easier to name. A light can be photographed. A radar return can be logged. But some anomalies seem to retreat the moment we build a machine to catch them. In Taos, New Mexico, residents began describing a persistent low-frequency hum that seemed to vibrate through walls, beds, and bodies. Not everyone could hear it. Estimates often centered on a small percentage of the population, enough to suggest a real human experience, but not enough to make the sound universal. In the early 1990s, the complaints attracted official attention, including investigation involving scientific and technical groups. Researchers looked for industrial sources, acoustic patterns, electrical systems, geological causes, and other explanations. The strange part was not that people heard a hum. Low-frequency noise can come from many places. The strange part was that conventional microphones and measurements struggled to capture what some listeners insisted was physically present. For those who heard it, the hum was not an idea. It was a pressure, an intrusion, a private disturbance in a public world. Imagine lying awake in the desert night, hearing something no instrument can confirm, wondering whether the failure belongs to your senses or to the equipment. Some have imagined it as a background vibration of reality itself, a kind of hardware noise beneath perception. That remains speculation. But the human meaning is harder to dismiss. Not every anomaly appears outside us. Some arrive through the body, and the body is not just a witness. It may be part of the mystery. At the scale of cells, the world becomes less like a machine made of parts and more like a weather system made of probabilities. Quantum tunneling is one of the most counterintuitive facts in modern science. A particle can pass through an energy barrier it classically should not cross. It does not break through like a bullet through glass. It appears on the other side because, in quantum terms, its presence is spread as probability rather than fixed as a tiny stone. For many years, this sounded like a phenomenon belonging to laboratories, stars, and exotic physics. But research into biology has suggested that tunneling may play roles in ordinary life. Enzymes may use it to move hydrogen particles during chemical reactions. Some models of mutation and DNA behavior consider quantum effects at tiny scales. Photosynthesis, smell, and other biological processes have also been discussed in relation to quantum behavior, though the strength of the evidence varies by case. The phrase, matter ghosting through matter, is poetic, not technical, but it points toward something real. Life may depend in part on processes that defy our everyday intuition about solidity. This links to an older human fascination with the body as more than flesh, not because the body is supernatural, but because the deeper science of the body is stranger than folklore ever needed it to be. The midpoint of the journey is here. The anomaly is no longer only out there in the sky or in the desert. It may be happening quietly inside us. The idea that human beings are separated from reality by a clean boundary begins to weaken when we look closely enough. A body is not a sealed object moving through the world. It is chemistry, electricity, heat, memory, pressure, breath, and perception. It responds to light before we notice the room has changed. It adjusts to sounds before we name them. It carries clocks in cells, rhythms in hormones, and signals that pass through darkness faster than thought. This is why quantum biology feels like a turning point. It does not require us to claim that consciousness controls the universe. It asks a quieter question. What if life evolved to use the universe at levels our senses were never designed to see? The popular imagination often reaches for words like energy, frequency, and vibration, sometimes too quickly. Yet beneath the misuse of those words is a legitimate wonder. The living body is not merely assembled from matter. It is matter organized into attention, response, repair, and survival. If particles can tunnel, if enzymes can exploit probability, if the living world depends on behaviors that seem impossible at human scale, then our familiar picture of reality becomes incomplete. The mystery does not become smaller when we explain more. It becomes more intimate. And once we admit that the body and the world are entangled in ways we barely feel, another question rises. Can collective human attention leave a measurable trace? In the late 20th century, researchers connected random number generators in different parts of the world and began asking an unusual question. If large numbers of people experience the same emotional event at the same time, would devices designed to produce randomness show any deviation? This became associated with the Global Consciousness Project, connected to work at Princeton and other collaborators. The devices produced streams of data, and researchers compared those streams against moments of global attention, disasters, celebrations, acts of violence, and historical events that drew millions of minds toward a shared point. The most discussed claims involve major events such as September 11th and the Indian Ocean tsunami. Supporters argue that the data showed unusual departures from chance during periods of intense collective focus. Critics argue that the methods, interpretations, and statistical choices leave too much room for pattern finding after the fact. Both positions matter. The evidence is not a settled doorway into a new physics of thought. But the question is haunting because it touches something human beings have felt for centuries. That crowds, grief, prayer, fear, and hope may have a weight of their own. Even if the physical interpretation remains uncertain, the emotional truth is plain. When humanity turns together toward a single event, the world feels different. The unresolved question is whether that feeling lives only inside us, or whether some fragile instrument has occasionally trembled at its edge. Old maps carry a special kind of silence. They show not only what people knew, but what they believed they knew, what they inherited, and what they dared to draw across blank space. The Piri Reis map, created in 1513 by an Ottoman admiral, has become one of the most discussed artifacts in alternative history. It includes coastlines of parts of the Atlantic world with remarkable detail for its era. Some interpreters have claimed it shows Antarctica without ice, suggesting access to ancient knowledge far beyond the accepted timeline. The cautious view is more restrained. Scholars generally debate whether the southern landmass on the map represents Antarctica at all, or whether it reflects distorted information about South America and other known coastlines. The claim about ice-free Antarctica remains controversial and far from settled, yet the map still matters. It reminds us that history is not a clean staircase. Knowledge moves through sailors, prisoners, libraries, empires, merchants, fires, translations, and lost originals. A single surviving sheet of parchment may contain fragments of many vanished worlds. The anomaly, then, may not be proof of impossible geography. It may be proof that human knowledge has always been more fragile and more connected than the official timelines make it appear. And if one old map can make us question what survived, one old machine can make us question what was possible. It began as corroded fragments pulled from an ancient shipwreck near the Greek island of Antikythera. At first, the object looked like ruined bronze, another remnant from the sea's long appetite. Then, researchers looked inside. X-ray imaging revealed gears, inscriptions, and a complexity that seemed out of place for an object more than 2,000 years old. The Antikythera mechanism is now widely understood as an ancient Greek device used to model astronomical cycles, including movements of the sun, moon, and perhaps eclipses and calendar systems. It is not a computer in the modern electronic sense, but it is a machine of calculation, memory, and prediction. It shows that ancient engineering could reach levels of precision many people once assumed arrived much later. This is one of the most important distinctions in any mystery. An object can be extraordinary without being impossible. The Antikythera mechanism does not prove lost aliens, broken timelines, or secret physics. It proves that our assumptions about the past were too small. That may be the deeper anomaly. Not that history contains magic, but that human intelligence repeatedly exceeds the story later centuries tell about it. When the mechanism's gears are imagined turning again, we hear a message from antiquity. The past was thinking. The past was calculating. And in other places, where the evidence is weaker and the claims more uncertain, the same desire to understand becomes more dangerous. On a remote mountain in China, stories about the bygone pipes have circulated for years. Strange pipe-like formations embedded in rock, sometimes described as metallic, sometimes linked to claims that they predate known human metalworking in the region. The reality is difficult to pin down. Some investigations suggest natural geological explanations, such as fossilized tree roots or mineral formations shaped over long periods. Other accounts emphasize unusual chemical compositions and the unsettling geometry of the structures. As with many contested anomalies, the public story often grows faster than the evidence. The Baltic Sea anomaly follows a similar pattern. In 2011, a sonar image from the floor of the Baltic Sea showed an unusual formation that some compared to a crashed craft or a manufactured object. Later discussion included claims about equipment malfunctioning nearby, though such claims remain debated and difficult to verify independently. These cases belong in a documentary not because they prove a hidden architecture of reality, but because they reveal how mystery behaves in the modern age. A grainy scan, a geological oddity, a translated report, a missing measurement. Each can become a screen on which we project both wonder and fear. The careful path is not to ridicule curiosity and not to surrender judgment. It is to hold both at once. Some anomalies ask us whether reality is strange. Others ask whether we are patient enough to separate strangeness from story. Memory may be the most intimate evidence we ever possess, and the least reliable. The Mandela Effect describes moments when large groups of people remember something differently from the available record. A phrase from a children's book, a logo, a movie line, a public event. For those who experience it, the feeling can be deeply unsettling. It is not simply forgetting. It feels like remembering a world that has been edited after the fact. Some theories have linked these mass memory conflicts to high-energy experiments at CERN and the Large Hadron Collider, suggesting that particle collisions might somehow create tiny mergers between neighboring realities. There is no established scientific evidence for this claim. CERN's work is documented, technical, and grounded in particle physics, not reality alteration. Yet the theory persists because it gives shape to a real emotional experience. We live in an age where images change, archives update, feeds vanish, and digital memory feels both permanent and unstable. When personal memory clashes with public record, it can feel as if the world has moved without asking permission. The more grounded explanation lies in psychology, suggestion, repetition, cultural reinforcement, and the reconstructive nature of memory. But even that explanation is profound. If memory can create such convincing alternate pasts inside us, then reality is not only what exists, it is also what the mind can no longer stop believing. By now, the pattern has become more interesting than any single case. A particle behaves differently when measured. A valley glows with lights that instruments can partly record, but not fully explain. A desert town hears a hum that resists easy capture. Biology uses quantum behaviors beneath the scale of touch. Ancient artifacts reveal forgotten sophistication. Human memory bends, gathers, and sometimes disagrees with the world outside it. Not all of these belong in the same category. Some are solid science. Some are open investigations. Some are disputed claims wrapped in fragile evidence. Some may eventually be explained in ordinary terms, but together, they expose a human habit that is both dangerous and beautiful. We keep asking where the edge of the known truly lies. The danger is rushing too quickly toward certainty. The beauty is refusing to let mystery disappear just because it is inconvenient. For viewers who remember the mystery of the pineal gland as an inner world question, this is its outer world counterpart. There, the puzzle was consciousness, symbolism, and the body's quiet darkness. Here, the puzzle is environment, matter, memory, and the strange behavior of evidence itself. Maybe the world is not hiding from us. Maybe it is simply deeper than our instruments, stories, and assumptions can reach at the same time. And the final question is not whether every anomaly is true. It is what remains after the weak explanations fall away. At the beginning, we asked whether reality is a fixed state or a program with bugs. After moving through laboratories, valleys, deserts, shipwrecks, old maps, biological cells, random number generators, and human memory, the honest answer is still incomplete. Reality has not confessed to being a simulation. The evidence does not allow that kind of certainty. But the world has also not returned to being simple. What we can say is quieter and more enduring. The universe is not obligated to match human intuition. Matter does not always behave like the solid objects of daily life. The past was not always as primitive as we imagine. Memory is not a perfect archive. Measurement is not always passive. And mystery, when treated carefully, can become a form of respect. The seams of reality may not be cracks. They may be places where our understanding has not yet grown strong enough to cover the light coming through. Which of these documented cases feels most difficult to explain away is a question each viewer will answer differently. The more important question may be why we need reality to be so final in the first place. Perhaps truth is not a locked room waiting to be opened once. Perhaps it is a horizon, moving as we move, sharpening as we look, and reminding us that wonder is not the opposite of reason. It is one of the reasons reason began.